Start by taking a look at the conditional probability homework. So number 1, there are 27 students in the class, 15 take art and 20 take theater. 4 do neither. How many do both subjects? So let's make a Venn diagram here. And what number do we know goes on the, let's see, 4 take neither. We're going to put 4 on the outside, so we have art and theater. We don't know how many take both, so x in the center. So there'd be 15 minus x over here, 20 minus x over here. So if we were to write our equation, we have 15 minus x plus 20 minus x plus 4 equals 27. So that's 35, so that's 39 minus 27, minus x equals 27. So that means x has to be 12. So if we went and filled in these numbers, we got 12 in the center. 20 minus 12 is 8. 15 minus 12 is 3. So how many do both subjects? Well, that would be 12. He or she takes art, but not theater. So she takes, he or she takes theater, but not art. So that would be 8, and we're still looking at our total of 27. He or she takes at least one of the 2 subjects. Well, how many take at least one? That would be the numbers in the middle. So we have 3 plus 12 plus 8, so we have 23 out of 27. He or she takes theater given that he or she takes art. So this is our given. So we're really only looking at that 15, and how many are in theater is 12 out of those 15. So the second one here, for events A and B, it is known that not A and not B is 0.35. The probability of A is 0.25 and the probability of B is 0.6. And then we have some probabilities to find. So let's see if we can draw a Venn diagram again. So we have A and B. So we know not A and not B is 0.35. So that means 0.35 has to be on the outside. And then we don't know this, so we can do x. So 0.6 minus x, 0.25 minus x. So if we add all these together again, so 0.25 minus x plus 0.6 minus x plus 0.35, that's our total of 1. So we have 0.95, so we have 1.2 minus x equals 1. So x has to be 0.2. So if we put these in here, so we have 0.2, this would be 0.4, 0.25 minus 2, 0.05. So find the probability of A and B. So that number in the middle, A and B, would be 0.2. Find the probability of A given you're in B. So B, our circle, is 0.6. So the probability that you're in A given B, so we're looking right at that circle, and what's the probability that you're in A would be 0.2. So we have 2.6. The probability of B given that you're not in A. So we're looking at the not A's. So if I highlight everything that's not A, so here's our not A's. So that's 0.4 plus 0.35, so we have 0.75, that you're not in B. Well, of that chunk, what's not in B is only the 0.35. So 0.35 out of 75, so 35 out of 75. The next one here, a number is chosen at random from the list of 8 numbers. Find the probability that it even, given it is not a multiple of 4. So let's see, our not multiples of 4. So we're looking at 1, 7, 11, 22, and 29. So we're looking at 5 numbers. Did I miss one? 1, 2, oh, I forgot 2. So we're looking at 6 numbers. And of those 6, how many are even? So we have 2 out of 6. The probability is less than 15 if it is greater than 5. So if it's greater than 5, we're looking at 7, 11, 16, 22, and 29. So we're looking at 5 numbers. How many are greater than 15? 1, 2, 3. So we have 3 out of 5. So this next one, it is less than 15. So we're looking at 1, 2, 4, 7, 11. So we're looking at those 5 numbers. And we want it is less than 5. So we have 3 out of 5. The probability it lies between 10 and 20 if it lies between 5 and 25. So the numbers we're looking at are 7, 11, 16, and 22. So of those 4, it lies between 10 and 20. So we have 2 out of 4. This bottom one, in a town of 95% of all households have a desktop computer, 61% have a desktop computer and a laptop. What is the probability that a household has a laptop given that it has a desktop? So we're asking, I'm going to put some notation here, the probability that you have a laptop given you have a desktop. Well, our definition of conditional is the probability that you have a laptop and a desktop given that you have a desktop. So our probability of a desktop is 0.95. The 61% of all households have a desktop and a laptop, so that'd be 6.61. So we have 61 out of 95. Number 5 here. U and V are mutually exclusive. So mutually exclusive, so they don't have any overlap. So we have 0.26 and 0.37. So we have U and V. What is the probability of U and V happening? Well, they're mutually exclusive, so it's 0. The probability of U given V. So this is our definition for the probability of U and V divided by the probability of V. So we got 0.37, we know it's 0, so it would be 0. U or V, well, they're mutually exclusive, so we can just add them. The probability of one of them happening would be 0.63. The next one here, a jar contains black and white marbles. 2 marbles are chosen without replacement. The probability of selecting a black marble, then a white marble is 0.34, and the probability of selecting a black marble on the first draw is 0.47. What is the probability of selecting a white marble on the second draw, given that the first marble drawn is black? So this is the probability that you select a white, given that the first one is black. So this is the probability of white and black over the probability of just black. So, and the probability of selecting a black marble on the first draw is 0.47. The probability of selecting a black marble then a white marble is 0.34. So we have 34 over 37. J and K are independent events. Given that probability of J given K is 0.3 and the probability of K is 0.5, find the probability of J. So let's see here. So I'm going to use that definition. So the probability of J given K equals the probability of J and K divided by the probability of K. So we can fill a couple of these in. The probability of J given K, so 0.3 equals the probability of J and K divided by our probability of K is 0.5. So if we solve this and multiply by 0.5, we have 0.15 equals the probability of j and k. Well, we know that they're independent, so the probability of j and k equals the probability of j times the probability of k. So we can fill in a couple more blanks here. So 0.15 equals the probability of j times 0.5. So we can divide by 0.5, divide by 0.5. So 0.3 equals the probability of j.